Friends, today we are going to talk about resistors in series. Now, there are different ways of connecting resistors. The two ways are one in series and the next one in parallel. When I am saying resistors in series, it means that there are two resistors and they are connected one after the other. For example, I have resistor 1, R1, and this is resistor 2. They are connected one after the other. A very simple example of that in life is where we see the fairy lights, or what we say in Malayalam, the Perunal lights that we put, they are connected in series. Now, in series, you will find that there are each resistor has got two endpoints A and B. So R1, the endpoints are A and B. R2, the endpoints are B and C. When R1 and R2 are connected in series, we will find that there is one endpoint which is common between the two resistors. So here, when two resistors are in series, we will find that one endpoint is common in between the two. So that is the main thing that we have to remember. Between the two endpoints, one endpoint will be common between the two resistors. Let us now see over here what are the characteristics of resistors in series. I have got a circuit. I have connected two resistors in series. I have got a battery. I have got a key and I have got an ammeter. Whenever we connect an ammeter, please remember that the positive terminal of the battery should be connected to the positive terminal of the ammeter. Okay, so please remember that. Now, what we are going to do is we are going to switch on the current. So, I am going to place the key and now the current flows. Current always flows from the positive terminal of the battery to the negative terminal. When the current flows, I'll find that there is a current in there is a reading is shown in the ammeter. I note down what is the reading. Let me say that the reading in the ammeter is I, one particular value. Now, next what I am going to do is I am going to disconnect the ammeter from here and I am going to keep the ammeter in some other position. So see, I have kept it between R1 and R2. Again, when I switch on the current, I'll find that the reading in the ammeter, I'll note what is the reading in the ammeter. I find that the reading in the ammeter has not changed. It is the same, that is I itself. Similarly, if I take the ammeter and I disconnect from here and I place it maybe after the two resistors, also I'll find that there is no change in the reading. That means, what does this mean? It means that the current is constant. Okay, the current is same or the current is constant. So I will say over here the first characteristic, I is constant. So what do you mean by that? Wherever I place the ammeter, or the same current flows through every part of the circuit in series. Did you get what I said? The current is the same in whichever part of the circuit. Now we go on, we take a voltmeter. Okay, so a voltmeter I have taken, I have connected it across the two resistors. Again, we must remember positive of the battery should be connected to the positive terminal of the voltmeter. I am going to close the key. A current flows through the circuit. I'll find that now there is a reading in the voltmeter. I note what is the reading and I'll see that the reading is one particular reading, let's say it is V. Now what I'm going to do is I'm going to disconnect the voltmeter from here. And let me say that I'm going to put the voltmeter across one resistor. Okay, only across R1. When I put the voltmeter across R1, I note what is the reading in the voltmeter. I'll find that now the voltmeter reading has changed. There is a different reading. Okay, and this reading in the voltmeter, I will note it as V1. Okay, so what did I do? I connected it only across R1. Earlier I had connected it across both the resistors. Now I am going to disconnect from here and I will connect it across R2. Okay, what will happen? Yeah, the reading will again will it be the same? Will it be different? Or will it be the same as V1? What will be the reading? Here we see that it is completely different reading. So now the reading has become V2. Okay, so another reading is there that it is V2. Okay, so three different readings. First across both the resistors, then across only R1, then across R2. Okay, so I have got three readings, V1 and V2. Let me just say over here, I am going to give you some values for V1 and V2. Let's suppose the value of V that I measured is say around 3 volt. Okay, and V1 reading when I got it as maybe 2 volt, and the V2 reading I find is 1 volt. So these were the readings that I got. Okay, so looking at the readings, what relationship do you find between these three readings? Yes, 3 is equal to 2 plus 1. So if I am going to write it in terms, what will I say? V is equal to V1 plus V2. Okay, so that is my second point. Okay, second characteristic. So what does it in words, how can I say? The total potential difference is equal to sum of, okay, potential difference across individual resistors. That is how we say it in words, or you can just keep it in mind. V is equal to V1 plus V2. So total potential difference is equal to sum of potential difference across individual resistors. Okay, now what I am going to do is I am going to remove all these resistors and I will have just one resistor which is an equivalent resistor. Okay, equivalent resistor means it is the of R1 and R2. Okay, now this equivalent resistor has got a resistance R. Okay, the potential difference across the resistor R is V. Okay, V, and the current flowing through it is I. Okay, so I've got one resistor. The potential difference when I measure using a voltmeter is V, and the current flowing through it is I. Let me apply Ohm's law for this resistor. What is Ohm's law? Okay, V is equal to, do you all remember? I, the current, into R. So that is for that equivalent resistor. V is equal to IR. Let me take this as the first one. Okay, now I am going to apply Ohm's law to the individual resistors. Okay, that means V1 potential difference across R1 and V2 potential difference across R2. If I say V1 is equal to, what is it? It is IR1. Why did I say IR1? Because current is the same, the resistance is different. Okay, that is second one. If I apply potential difference across V2, if I apply Ohm's law, so what will it be? Current is the same. We are saying that I is constant. So we will say I R2. This is my third one. Okay, let me substitute. Okay, let me take this as first equation, second, third, and this is the fourth one. Let me substitute 2, 3, 4 in 1. Okay, so what do I get? I get IR is equal to IR1 plus IR2. What do I see? All the terms have got I. So I can remove out I. So I remove out I. Because all the terms have got, I can cancel like this guy. So what is left? R is equal to R1 plus R2. And this is my third characteristic. So what does this mean? R means total resistance is equal to sum of individual resistances. Okay, so kindly go through this once more and let me know if you have not understood anything. Thank you.